We're going to be tackling a topic that's so mind-bending, it had even Einstein scratching his head.
Yeah.
You ready to explore proton entanglement?
Let's unravel it.
Perfect. Now, we all know protons, right?
Right.
Those tiny particles all huddled together in the nucleus of an atom.
Yep.
But here's where it gets really interesting.
Okay.
Scientists are discovering that the very building blocks of protons, those quarks and gluons, can be linked in this bizarre way called entanglement.
It's not just that protons themselves can be entangled,
Right.
which is wild enough.
Yeah.
It's the entanglement within a single proton.
Whoa.
Imagine these tiny particles, quarks and gluons,
Yeah.
instantly influencing each other's behavior no matter how much space separates them.
It's like they're having a secret conversation across these incredibly tiny distances.
That's a good way to put it.
So how did scientists even begin to peek into this subatomic world and figure out what's going on?
They essentially created a subatomic demolition derby.
Okay.
Scientists at Brookhaven National Laboratory smashed protons and electrons together at incredibly high speeds.
Oh.
Then, by carefully analyzing the debris from these collisions, they could piece together what was happening inside the protons.
So they couldn't actually see entanglement happening,
Right.
but they could deduce it was there based on the patterns of the scattered particles.
Exactly. Think of it like trying to understand the shape of a stone that's been thrown into a pond.
Okay.
You can't see the stone itself,
Right.
but you can learn a lot by studying the ripples it creates.
That's a great analogy.
Thanks.
So let's get to the big question.
Okay.
Why is this discovery such a game changer?
Well,
Why should we care about entanglement happening at such a tiny scale?
this finding completely reshapes our understanding of protons.
Okay.
They're not just simple bundles of particles as we once thought.
Right.
They're dynamic, interconnected systems. And this has huge implications for some of the most fundamental theories in physics.
Like quantum mechanics. I remember learning a bit about that in school.
Yeah.
Something about particles existing in multiple states at the same time.
That's right. Quantum mechanics tells us that particles can exist in a superposition of states,
Okay.
meaning they're in multiple states simultaneously until we try to measure them. And this idea is absolutely key to understanding entanglement.
But how does entanglement actually work?
Yeah, that's the million-dollar question.
Right.
And it's one that's baffled physicists for decades. Entanglement seems to operate outside the realm of traditional physics, defying our everyday notions of space and time.
So we've got this mind-boggling phenomenon happening inside protons, potentially overturning our understanding of physics as we know it, and yet we don't even fully grasp how it works.
A bit of a paradox, isn't it?
Yeah.
But that's what makes this research so captivating.
Right.
We're peering into the unknown. And with every new discovery, we uncover more questions than answers.
That's the beauty of science, right? It's a constant process of exploration and discovery.
Yeah.
But I have a feeling this discovery about proton entanglement is going to lead to some incredible advancements down the line.
Absolutely.
Like what?
Well, understanding how entanglement operates at the subatomic level could unlock the potential of quantum computing.
Oh, wow.
Imagine computers so powerful that they could solve problems that are currently impossible for even the most advanced supercomputers.
We're talking about revolutionizing everything from medicine to material science to artificial intelligence.
Exactly.
That's definitely something to be excited about.
It is, and beyond its practical applications, this research also sheds light on the very fabric of the universe.
Okay.
It helps us probe the fundamental building blocks of matter and the forces that govern them.
Okay, so we've established that this discovery is huge.
It is.
But I'm still a bit hazy on how this specific finding entanglement inside a proton is different from the general idea of entanglement that we've been hearing about for years.
That's a great question. You see, previously, most research on entanglement focused on entangling separate particles. For example, entangling two photons or two electrons.
Right.
This new research shows that entanglement isn't just something that happens between separate particles.
Okay.
It's happening at an even deeper level within the very structure of a single particle.
Ah, so this isn't just about two protons being entangled,
Right.
but about the entanglement within each proton.
Exactly.
This adds a whole new layer of complexity.
It does. It suggests that entanglement is a more fundamental property of the universe than we previously thought.
It's like we've been studying the branches of a tree, and now we're realizing that the roots are intertwined in a way we never imagined.
I like that.
It completely changes our understanding of how the whole system works.
Perfect analogy.
And speaking of understanding how the whole system works,
Yeah.
there's another fascinating piece to this puzzle that we need to discuss.
Okay.
Remember that theory you mentioned?
Yeah.
The one that governs how quarks and gluons interact? Uh-huh.
You mean quantum chromodynamics?
Yes.
That sounds pretty intense.
It is a complex theory, but think of it this way.
Okay.
Quantum chromodynamics, or QCD for short, is like a rule book that governs how the particles inside protons interact. And surprisingly, this rulebook seems to allow for entanglement.
So the fact that we're observing entanglement inside protons actually confirms a prediction made by QCD.
It does.
That's a pretty big deal, right?
It is.
Wow.
It means that our theoretical understanding of the universe is aligning with what we're observing in experiments.
That's incredible. It's amazing how all these pieces fit together, experiments, theories, and this mind-boggling phenomenon of entanglement.
It is fascinating, isn't it?
Yeah, but I'm still grappling with how entanglement can seemingly defy the laws of physics.
I know what you mean.
It just feels so counterintuitive.
It does. It challenges our everyday understanding of how the world works.
Right.
We're used to cause and effect happening in a local way.
Yeah.
Like, you touch something here, it moves there.
But entanglement suggests that there's a deeper level of connection between particles that transcends our typical notions of space and time.
So, are there any theories out there that attempt to explain how this spooky action at a distance actually works?
There are many different interpretations of quantum mechanics,
Okay.
each with its own strengths and weaknesses. Some physicists believe that entanglement points to a deeper level of reality,
Okay.
where the separation between particles is just an illusion.
Wow.
Others suggest that there are hidden variables at play that we haven't yet discovered.
So it sounds like we're still in the very early stages of understanding this fundamental aspect of the universe.
We are, but even though we don't have all the answers yet,
Right.
we're still making strides in figuring out how to use entanglement to our advantage.
Like how?
Well, the potential applications of entanglement, particularly for quantum computing, are incredibly exciting.
Correct.
Imagine being able to perform computations that are currently impossible, even for the most powerful supercomputers.
Like what kinds of computations are we talking about here?
You're talking about things like developing new life-saving drugs, designing revolutionary materials, or creating truly intelligent AI.
It's mind-boggling to think about the possibilities.
It is.
And all of this hinges on our ability to understand and control entanglement.
Exactly.
Speaking of controlling entanglement,
Yeah.
there's a new facility on the horizon that has physicists buzzing with excitement, the Electron-Ion Collider.
That's right.
Can you tell us more about that?
The EIC is a next-generation particle accelerator that's being built in the United States.
Okay.
It's going to allow scientists to collide electrons and ions at much higher energies than ever before,
Wow.
giving us a much clearer picture of what's happening inside protons and other subatomic particles.
So it's like upgrading from a basic microscope to a state-of-the-art electron microscope.
Exactly.
We're getting a much more detailed and refined look at this tiny quantum world.
Precisely.
Yeah.
And with this increased resolution,
Yeah.
we'll be able to probe the intricacies of proton entanglement in ways we can only dream of right now.
I can already feel the excitement building in the scientific community. But before we get carried away with the future possibilities, let's make sure we've covered all the bases.
Okay.
We've talked about the experiment at Brookhaven, the implications for quantum computing, and the potential of the EIC.
Right.
Is there anything else we need to touch on regarding the significance of this proton entanglement discovery?
Well, there's one aspect we haven't discussed yet that really highlights the importance of this finding.
Okay, what's that?
It has to do with a concept called entanglement entropy.
Okay, entanglement entropy.
Yeah.
That sounds pretty complex. Break it down for me. How do you measure something as abstract as entanglement?
Entanglement entropy is a way to quantify the amount of entanglement present in a system.
Okay.
Essentially, it measures how much information is shared between entangled particles. The higher the entanglement entropy, the more strongly entangled the particles are.
So it's like a gauge of how interconnected those particles are.
Exactly. And by calculating the entanglement entropy of protons, we can learn more about their internal structure and how entanglement influences their behavior.
So it's not just about knowing that entanglement exists, but understanding how much entanglement is present and how that impacts the properties of these fundamental particles.
Precisely. And here's where that theory we discussed earlier, quantum chromodynamics comes back into play.
Okay.
QCD not only allows for entanglement,
Right.
but it actually predicts that entanglement should be a fundamental feature of protons.
So the experimental evidence we've been talking about, the discovery of proton entanglement, actually confirms a prediction made by QCD.
Yes, and that's why this discovery is so significant. It's a beautiful example of how theoretical predictions and experimental observations are coming together to paint a more complete picture of the universe.
It's almost like we're piecing together a giant jigsaw puzzle.
I like that.
And this discovery of proton entanglement is a key piece that helps us see the bigger picture more clearly.
It is, and just like with a jigsaw puzzle, sometimes finding one key piece can unlock a whole new section of the image, leading to a deeper understanding of the whole.
I have a feeling that this proton entanglement discovery is going to unlock a lot of new insights in the years to come.
I think so, too.
I'm particularly curious about how it will impact our understanding of the universe as a whole.
Yeah.
We've been talking about protons, which are incredibly tiny.
Right.
Does this finding have any implications for larger systems like atoms or molecules?
That's a fascinating question, and one that researchers are actively exploring.
Okay.
If the particles within a single proton are entangled,
Yeah.
could there be entanglement connections across larger distances? Within atoms?
Yeah.
Within molecules?
And if so, what would that tell us about the nature of reality itself? Would it mean that everything in the universe is interconnected in ways we can't even fathom?
That's where things get really philosophical.
Yeah.
Some physicists speculate that entanglement could be the glue that holds the universe together,
Wow.
connecting everything in ways we can't even begin to imagine.
So this tiny discovery about protons could potentially have implications for our understanding of the entire cosmos.
It's certainly possible.
That's incredible.
We're still in the early stages of understanding entanglement,
Right.
but it has the potential to revolutionize our view of the universe and our place within it.
It's like we've stumbled upon a hidden doorway that leads to a whole new realm of understanding.
I like that.
And we're just beginning to explore what lies beyond that door. It's incredible to think that something as seemingly insignificant as a proton could hold such profound secrets about the universe. I'm starting to see why physicists are so captivated by this research.
It's truly a testament to the interconnectedness of everything. Who would have thought that by smashing tiny particles together, we could gain insights into the very fabric of reality?
It's like those old sayings, the smallest things can make the biggest difference, or the universe is reflected in a grain of sand.
Yeah.
They're starting to take on a whole new meaning for me.
Exactly. And the more we delve into the quantum world, the more we realize that our everyday intuitions about how things work simply don't apply. It's a realm of endless possibilities and mind-bending paradoxes.
It's almost like we're having to relearn everything we thought we knew about the universe, but I have to admit it's exhilarating. It's like we're explorers setting foot on uncharted territory.
I couldn't agree more, and we've only just begun to scratch the surface. There are so many mysteries left to uncover, so many questions still unanswered.
Speaking of unanswered questions, we've been talking about how entanglement might extend beyond protons, potentially connecting atoms and molecules. What are the implications of that? Could it be that entanglement plays a role in the formation of larger structures in the universe?
That's one of the big questions that researchers are grappling with. Could entanglement be involved in the way atoms bond together to form molecules, or in the complex interactions within living organisms? We simply don't know yet, but the possibilities are tantalizing.
It's like we're looking at the universe through a new lens, one that reveals hidden connections and a level of complexity we never imagined.
Precisely. And this new perspective could have profound implications for our understanding of everything from the origin of the universe to the nature of consciousness itself.
Those are some pretty big ideas. I'm feeling a bit overwhelmed, to be honest. Where do we even begin to explore such vast concepts?
Well, the key is to keep asking questions, keep experimenting, and keep pushing the boundaries of what we think we know. And that's where facilities like the Electron-Ion Collider come in.
Right, the EIC. It's going to be a game changer for this type of research, isn't it?
Absolutely. With its ability to probe protons with unprecedented precision, the EIC will provide invaluable data that will help us refine our theories and deepen our understanding of entanglement.
It's exciting to think that we're on the cusp of a new era of discovery in the quantum realm. What are some of the specific things that scientists hope to learn using the EIC?
Well, one of the key goals is to measure the entanglement entropy of protons with much greater accuracy. This will give us a much clearer picture of how much entanglement is present and how it influences the behavior of these particles.
So we're not just confirming that entanglement exists, we're going deeper and trying to quantify it.
Exactly. And by combining these precise measurements with theoretical calculations based on quantum chromodynamics, we can start to build a more complete model of how protons work at the most fundamental level.
It sounds like a monumental task, but also incredibly rewarding. It's like we're piecing together the ultimate puzzle of the universe.
It is a challenging endeavor, but that's what makes it so exciting. Every new discovery, every step forward, brings us closer to understanding the profound mysteries of the quantum world.
This deep dive has been a truly mind-expanding experience. I feel like I've gained a whole new appreciation for the complexity and interconnectedness of the universe. Any final thoughts for our listeners before we wrap things up?
I would simply encourage everyone to stay curious. Keep exploring, keep asking questions, and never lose your sense of wonder. The universe is full of surprises, and who knows what incredible discoveries await us just around the corner.
Well said. It's a reminder that the journey of discovery never truly ends. Thanks for joining us on this exploration of proton entanglement. Until next time, keep looking deeper.